Hello folks, so today we're going to be looking at multiplying and dividing powers. So the reason why I'm making this video is because I, as a student who has graduated from elementary school, am still confused about why we would do something like this. So to kind of explain how we do this, I'm going to use x. So for those unfamiliar with algebra, x just means an unknown number. So this does represent a number if we say it's equals to something, but right now x is just kind of an example. It could be any number. So right now x just represents any number, 1, 2, 3, 4, 5, whatever. Okay, if we do x cubed, so that's what it means when you raise it to the third power for those unfamiliar, times x cubed, and this little dot just represents multiplication because otherwise we'd have to use x times x with a third x, and that just doesn't look very good. So x cubed times x cubed would equal x to the sixth power. And for me, that was confusing because I used to think, wait, shouldn't this be to the ninth power? Because we're multiplying, we're not adding or subtracting. Well, here's the truth. So the first thing we need to look at is what does an exponent do really? So if we think about any number squared, so I'll go one exponent lower just to kind of make this easier. So if we go one exponent lower, x squared is literally just x times itself. And remembering that x is any number, that's just whatever number x is times itself. So if you have 1 squared, that's 1 times 1. If you have 2 squared, that's 2 times 2. If you have 15 squared, that's 15 times 15. You see? So it's a number times itself. And that's what an exponent does. It multiplies a number. And let me write this formula here. So this formula looks like a to the m. And so this can be a little confusing. Why aren't we using x? Why aren't we using y? Well, this is kind of an idea used later in math classes, and you'll see that a to the m means it's a times a times a, yada yada yada, m amount of times, right? So to make this simpler, if we have 2 to the third, that's 2 times 2 times 2, 3 times. You see? And so that a times a times a m stuff is not really something that you need to know right now to understand this. This is just me going more into depth about what the formula really is and how you'll see it later on in math. So when we take this problem, x cubed times x cubed, first let's figure out what x cubed is. X cubed, and we're just going to write this in parentheses to differentiate between this and that term, make it easier. Okay. Later in math, you'll also learn that when you put parentheses in a number, they multiply together. So 2 in parentheses, 4 in parentheses equals 8 because it's the same thing as 2 times 4. So this is just another way to write it that's a bit cleaner. So x cubed is x times x times x. And then x cubed is x times x times x. So our final equation is just x times x times x times x times x times x. This is x multiplied by itself 6 times. So this is equivalent to x to the 6th power. So therefore, that's why you add the exponents. If that doesn't make sense, look at it this way. If I tell you what x cubed times x is, you're going to say, well, that's easy because we know that x cubed is just x times x times x, and that's just adding another x. Not adding, but you get what I mean, right? That's just putting on another x, which is just x to the 4th. You're just taking x cubed, and you're doing x, you're just multiplying it by x again, which brings it up 1 power. And so this would be x4. But for me and my fallacious logic, fallacious being a play off of the word fallacy, that I'm not even sure is a real word, I would have thought that this would be x to the third. I would have said, well, that's probably x to the third,,, but that's wrong. It's x to the 4th. So now let's check division. So let's see why. So let's use kind of the same problem that we have here, but in reverse. So let me go ahead and I'll circle all of this. So we're going to go ahead and do x to the 6th divided by x to the 3rd equals x to the 2nd question mark? Nope. It equals x to the 3rd. And even when I knew this multiple rule right here, it still confused me because I thought, wait, division is different than multiplication. And one of the best ways to remember what division really is, right? Because when you have numbers, you can pretty easily define these symbols of operations in your own words. For example, if you're saying 2 plus 4, you can say, yeah, I have 2 pencils and I'm adding it to 4, right? If you have, x cubed times x cubed, you can say, yeah, I have something times itself 3 times and I'm multiplying by itself 3 times. But for me, when I look at this, I don't know how to make my own vocab sentence to represent this. Like, what? Am I taking x to the 6th and I'm putting it into 3 groups of x to the 3rd? Like, this doesn't, I wasn't able to rationalize that in my mind. And so the key thing to remember is that division is the opposite of multiplication. So they're opposites of each other. So, for example, if we take this and we say, well, what's x cubed divided by x? Well, that's going to be x squared. Because think about it. That's x times x times x and then divided by x. You see how we've multiplied by a third x, but then we've also divided that x out of the equation. So we end up getting rid of one of the x's that was multiplied because we're dividing it by x to the 1st power, so we're dividing it by 1. So now we're just left with x squared because they're inverses. So when you do division, it kind of undoes multiplication. I was going to say undoes there. That's not exactly a word. Is it a word? I don't know. So let's go ahead and check this out. So x to the 6th is x times x times x times x times x times x. And we'll use the parentheses to stay consistent with what we did last time. And then that's divided by x times x times x. Well, division is the inverse of multiplication. So it's kind of like saying x plus x plus x plus x plus x plus x minus x minus x minus x. You can just say, well, the plus and the minus are going to cancel out. The plus and the minus are going to cancel out. The plus and the minus are going to cancel out. And similarly, and it's actually funny, my math teacher has said that he doesn't like when people use cancel out, and this is just a fun trivial fact, not relevant to what we're talking about, but he says that he doesn't like it because canceling out typically will refer to when something equals 1. So you might say 2 divided by 2 cancels out, but you might also say 2 minus 2 cancels out. But in this case, 2 divided by 2 is 1, and in this case, 2 minus 2 is 0. So it's not super clear. In this case, by cancel out, I mean just kind of remove each other from existence. So to be more politically correct to the math teachers out there that are tired of its double meaning, right? And I doubt a math teacher would be watching this video unless they want to show it to their students, but they probably won't now because I just gone on a lecture that's unrelated to the video. Anyway, you see how addition and subtraction, they're inverses, and they cancel each other out. So similarly here, we can just cross out 3 of these x's, take out 3 of these x's, and we're left with x to the 3rd. And so that's kind of looking at it from a formula perspective and seeing that's why we add, or I guess in this case, subtract exponents from each other when we're dividing them. It's because when we look at what exponents actually are, multiplying them wouldn't make sense. Let's do a problem with numbers. So if using x to represent any number you could plug in didn't make a lot of sense to you, no worries. We're going to try and do the same thing that we kind of did. So I'll use maybe different problems. I'll probably do the exact same thing as the red, but I'll just use the number 2. So there's 2 ways that we can kind of represent this. The first way is we can just figure out what the numbers actually are. So what is 2 times 2 times 2? Well, 2 times 2 is 4. 4 times 2 is 8. So 2 to the third power, or 2 cubed, is just 8. And 8 times 8 equals what? Well, if you do your times table, or if you did your times table, you'll know it's 64. And what is 64? Is 64 2 to the 6th? Turns out it is. So check this out. 2 times 2 is 4, times 2 is 8, times 2 is 16, right? So that's to the second power, that's to the third. I guess this is a better way to write it. If I say this is 2, right? This is 3, this is 4, right? And then this is the 5th time that we've multiplied by 2, and then this is the 6th time. So I wrote it a bit lazily, because obviously we're not doing 64 to the 6th power, but this number in this case is just representing how many times we've multiplied it like this. So I wouldn't write it like this. This is just my weird notation. But as you can see, 64 is equal to 8 times 8, which is 2 to the 6th power. So you can see a proof with numbers how that's going to work. Similarly, if we inverse this, so if we say 2 to the 6th power divided by 2 to the third power, I, of course, would have said it's 2 squared, but it's actually 2 to the third. And we can prove that with numbers, right? So we can say 64 divided by 8, and I'm getting these numbers because we already figured them out over here. We figured out over here 2 cubed is 8, and 2 to the 6 is 64. Okay, 64 divided by 8 is going to be equal to 8. And is that a true statement? Yes, it is. What if we tried to fit in 2 to the 9th? So what if we said, okay, I'm still not convinced. Let's try and do this. Well, what is 64 times 2? 128. What's 128 times 2? I believe I'm actually going to have to do the math here. My apologies. 356-ish? No, it would be 256. What am I doing with my life? I added, okay, 256. Then what is that times 2? I already know that that's 512. Because I guess I must have skipped over this right here in my times table or whatever. So if we were to try and fit in a 9 here and say, well, yeah, you got to divide the exponents, we would end up getting 512 divided by 8 is equal to 8. And that's not true. I mean, you can work it out right here. And I'm just not switching over to a calculator so that I don't have to switch tabs. But if you do this out, right, the answer is not going to be 8, because 8 times 8 is 64. And similarly, 8 times 8 wouldn't be equal to 512. And so that's why 2 to the third times 2 to the third wouldn't be equal to 2 to the 9th. And we'll just do one more example in case you're like, well, I'm not sure. Maybe 2 is a special case where it works, but what if we do bigger numbers? Is it going to work with bigger numbers? Turns out it is. Let's go ahead. I'm trying to think of a number that I could quickly do in my head that wouldn't require me to pause the video to do math with. Okay, let's do 10. So let's say we have 10 to the 2 times 10 to the 5th. Okay, so these are bigger numbers here. That's going to equal 10 to the 7th. And we can prove that with numbers. We can say, well, 10 times 10 is 100. 10 times 5 is 100. 1,000 is 100,000. And we know that 100 times 100,000, so that's 100 groups of this, is going to be 10 million. And you can prove this with a calculator if you want. If you're still in arithmetic, and if you're not, you're probably tired of these explanations, but if you're still in arithmetic, multiplying by 10 can actually be super easy because you just end up adding zeros to the end. So that's why I'm able to kind of do this without a calculator. It's a neat little trick you could learn. And you'll definitely learn it by the time you get to middle school. So 10 to the 7th, right? That's 10 million, and 10 to the million is 10 to the 7th. So we've proved that that makes sense. If we try and do 10 squared times 10 to the 5th and make it equal something like 10 to the 10th, right? That's going to say, okay, well, that's 100 times 100,000, which is going to be equal to 10 billion. So let me write that out fully. So somehow you're going to come and tell me that 100,000 times 100 is 10 billion. Think about people that make $100,000 a year. After 10 years, will they have $10 billion? No, they will not. And that's sad, because I'm sure they would like $10 billion. But you don't add the exponents. I mean, oh my God, I just completely contradicted everything that I just said. You don't multiply the exponents, that's why you add, because we're adding them. Wow, that was a crazy good explanation, folks. We add them because we add them. Yep, I know, world's best guide. So, yeah, that's my best explanation for why we multiply and divide, of how we multiply and divide powers. Powers is just what a number and an exponent is called in an equation. So this is the base, this is the exponent, and so we say 2 to the power of 3. So powers is kind of just a way to reference that without saying numbers with exponents. But that's my best explanation. I hope this makes sense. If you have any questions, please comment them down below. I'll see you in the next one. Bye.